Right. When we are talking about the moles, right, you got to understand that let's suppose if I say hydrogen, helium, lithium, beryllium, are you understanding? So these are the elements. So this is atomic number one,
Yeah.
this is two, this is three, this is four, and this is five. Are you understanding?
Yes, ma'am.
So we have these elements, right? So we have one, two, three, four, five. So I hope you're understanding that in 10th grade we did that hydrogen's mass is also
Hmm.
one,
Hmm.
helium's mass is four,
Yeah.
lithium's mass is seven, beryllium's mass is nine, boron's mass is 11. Are you understanding?
Yes. Yes, ma'am.
Got my point?
Hmm.
So what do you understand from this part? So we would have we would be having this kind of scenario. Got my point?
Hmm. Yes,
Are you
ma'am.
understanding? So when
Yeah.
we are actually dealing with this,
Hmm.
what do you understand from
Hmm.
this part? That ma'am, if I say helium atom,
Hmm.
one helium atom. So I hope you're understanding that this is so small. It is so small that it would do what? It is so small that its mass cannot be measured.
Yeah.
What is
Hmm.
the mass?
Yes.
So for one atom, the unit
Hmm.
to measure small mass is U.
Yeah.
Are you understanding?
Yes, ma'am.
Got my point?
Yes, ma'am.
Got it?
Hmm.
So unit to measure small mass is U, and the value of
Hmm.
1 U is 1.67 into 10 raised to
Into
the
10
minus
raised to minus
24,
24
7 kg,
or
and in terms
24
of
gram.
grams, 1.67 into 10 ki power minus 24 grams.
Hmm.
So
Yes,
let's
ma'am.
suppose if I say that helium, we have an atom, and
Hmm.
inside the helium atom we have two protons and we had two neutrons.
Hmm.
So we would have for two protons we would have two electrons.
Hmm. Yes, ma'am.
Are you understanding? We would have two
Yeah.
electrons.
Yes, ma'am.
Any doubts in this?
No.
Got my point?
Yes,
So
ma'am.
if we have two protons and if we have two electrons, we have a neutral atom. So if I ask you what is
Hmm.
the mass of atom,
Hmm.
what is the mass of an atom? So it would be what? 2 times
Two.
mass of proton
Yeah.
plus 2 times mass of neutrons plus 2 times mass of electron. Are you understanding?
Yes, ma'am.
Got my point? But for the
Hmm.
fact we know that for the fact we know what? That the electron
Electron
has
has
what?
very little mass.
Electron has very little mass. You understand the point?
Yes, ma'am.
Electron has very little mass and that mass is too negligible.
Hmm.
So if that mass is extremely negligible, this shall be cancelled out.
Yes, ma'am.
And we know for the fact that the mass of proton is 1.672 into 10 raised to the power minus 27
Hmm.
kg, right?
Yeah.
And mass
Yes,
of
ma'am.
neutron is 1.674
Four.
into 10 raised to
Hmm.
the minus 27 kg. So
Yes,
if
ma'am.
I look at the values, if I look
Hmm.
at the values 2 and 4, what do you
Hmm.
understand from this part? If I look at the values of 2 and 4, what do you understand? Tell me.
Neutron is heavier.
We have 1.672 and we would have 1.674.
Hmm.
Got my point?
Yes, ma'am.
So when we are talking about the mass of an atom, what do you think is going to happen? Tell me. That
Uh.
2 times mass of electron would be cancelled out.
Hmm.
Are you
Yes,
understanding?
ma'am.
Because that's
Yeah.
negligible. So I would say
Hmm.
that if I do not see the third value, third digit, so
Hmm.
1.67 and 1.67, this would be the value.
Hmm.
So if I take this out, what do you understand? So mass of proton is nearly equal to mass of neutron.
Yeah.
Are you understanding? So that would mean
Yes.
2 times mass of proton plus 2 times mass of neutron. That will be 4 times
Hmm.
mass. Because if I consider the
Yeah.
same mass as M,
And MP and MN are nearly equal, so you can take
right,
them as M.
right. So I can say that is 4 times mass M. And this same value, 1.67 into 10 raised to the minus 24 grams, is taken to be U. So can I say
Hmm.
the mass of helium atom is 4U?
Yes, ma'am.
So similarly, let's suppose if I talk about sodium, so atomic number is 11, mass number is 23.
Yes,
Are you
ma'am.
understanding?
Yes, ma'am.
So we would have this atom. We would have 11
So,
protons and we would have 12 neutrons.
yes, ma'am.
So what do you think is going to happen? We would have 2 electrons,
2, 8 and 1.
8 and 1. So I
Hmm.
hope you're understanding that it is going to be 2, 8 and 1.
1.
Any doubts in this?
No, ma'am.
What do you understand from this?
Uh, so this would mean that the mass of a
So we would
sodium
have
atom would
11
be
protons. What would that
plus
mean? Just tell
12.
me. So we would have
So,
11 protons
hmm,
equals to 11 electrons and 12 neutrons. So what would be
hmm,
the mass of this entire atom? It would be 11 times mass of proton plus
plus
11
12.
times mass of electron plus 12
Hmm,
times mass of neutron.
hmm,
Now electrons mass is negligible, so we can cancel
hmm.
that out. You understand the
Yeah,
point? And
yes,
if we
ma'am.
cancel this out, so what do you think we're going to have? So we're going to have 23 because MP and Mn is
Hmm,
nearly the same value. So I'll say it is
yeah.
23 MP, or I can say it is 23 Mn if I put in the values. Instead
Hmm,
of Mn, I can put in MP, and instead of MP, I can put in Mn. Are you understanding?
yes, ma'am.
So you would have 23 MP, or we would have 23
Mn.
Mn. And rather than writing it down, I would write down 23U.
23U.
So can I say that 23U makes only one sodium atom?
Yes, ma'am.
Are you understanding? 23U shall
Hmm,
make one sodium atom.
yes, ma'am.
Any doubts?
No, ma'am.
So 1U shall make
1 by 23 of sodium atom.
1 by 23 of sodium atom. You understand? So what is
Yeah.
1U basically? What is 1U? 1U is 1 point. So rather than making 23 down, what do? You say that
Hmm,
23U is
yeah.
basically one atom. So 23U
Hmm,
is nothing but 1.67 into 10 to the
hmm.
power minus 23 grams
4. Yeah.
shall make
24, right, ma'am?
24, shall make one sodium atom. So if I have to make the value as 23, now 23
Hmm,
grams is a big number, right? Because
hmm,
23 into 1.67 into 10 to the power minus 24, that is going to
hmm,
be a smaller number. So
hmm.
23 grams, I'll take this value down. So that shall contain how
Yeah.
many atoms? That shall contain 1
6
upon
point,
1.67 into 10 to the power minus 24.
yeah, which is 6.022 into 10 raised to 23.
Right. So I hope you're understanding that 23 grams of sodium will have
Hmm.
these many atoms. So there,
Yes,
this
ma'am.
is where this number called 1 mole came.
Hmm.
So if you say 23U, it is the mass
Hmm.
of one sodium atom.
Yeah.
But instead of U, if you just put 23 grams, that would be the mass of
1 mole of sodium atom.
1 mole of sodium. Are you understanding or not?
Yes, ma'am. No doubt.
Got my point?
Yeah.
So now let's suppose if I say, so 1 mole of any substance would be equals to its gram
Atomic mass.
atomic mass, and that would be equals to 6.022 into 10 raised to the power 23
Hmm.
molecules or atoms.
Yes.
Are you understanding?
Yes, ma'am.
Got my point?
Yeah.
Any doubt in this system,
No, ma'am.
right? So basically, what do you have? And 1 mole will have this much gram atomic mass, these many molecules. And in
Hmm.
case of a gas, it shall be 22.4 liters.
Liter. Yeah.
In case of a
Under
gas, it shall be
NTP.
22.4 liters.
In NTP.
In entity, yes. Got it?
Yes, ma'am.
So now let's suppose if I give you that I have 46 grams of sodium with me, how many atoms would it contain? So you,
1.2044 into 10 raised to 24.
right. How did you calculate this?
Multiplied 6.022 into 10 raised to 23 by 2.
Yeah, why did you do that? That's my point. So you will say number of moles is equals to given mass
Hmm.
over molar mass.
Yes, ma'am.
How do you come to this formula? So you will say that, if the standard mass, so 23 grams of sodium
Hmm.
contains
Yeah.
1 mole Na.
Hmm.
You understand? So 1 gram of sodium contains
Contains
what?
1
1
by
upon 23.
23 mole.
So thereby 46 grams of Na.
Would contain 46 upon 23.
1 by 23 into 40.
Hmm.
So it shall be 2 moles.
Yes, ma'am.
Got my point?
Yes, ma'am.
Got the point?
Yes, ma'am.
2 moles of sodium atoms.
Hmm.
And if, let's suppose, if you say that 1 mole contains 6.022 into 10 raised to power 23 particles, so
Hmm.
2 moles would contain how much?
2 and
6.022 into 10 raised to power 23 into 2.
hmm.
Got the point? So
Yes,
now when
ma'am.
you understand this part, understand. Now let's suppose I make a solution. Okay.
Hmm.
Let's suppose I make a solution of what? Of some sugar and water.
Okay, ma'am.
So let's say if I take water and that water is 6 liters. And let's suppose if I add 18 moles of sugar into it.
Hmm.
So if I add 18 moles of sugar into it into 6 liters of water, got my point? What do you think
Yes,
is
ma'am.
going to happen? Got my point?
Mm-hmm.
So we would have 18
Moles of sugar.
in 6 liters of water. And you
Hmm.
understand that if this is water, let's say these black dots are
Yeah.
representing water. Okay. If these black dots are representing water, what would you say to this? You would say that, ma'am, sugar has gone into the spaces between water. So if you have taken
Yes.
6 liters water, I would say that
Hmm.
is also the volume of the solution.
Hmm.
Yes
Yes,
or
ma'am.
no? Because no more increase in
Yeah.
solution's volume is taking place.
Ma'am.
Are you understanding?
Yes, ma'am.
Got my point?
Yes, ma'am.
So that is the volume of the solution.
Hmm.
So what would you say? What would you say? That in 6 liters water
Hmm.
or in 6 liter solution,
Hmm.
how many total moles of sugar do we have? 18 moles of sugar.
18. Hmm.
So 1 liter solution,
3 mole.
18 by 6 moles
Hmm.
per liter. So that shall be 3 moles per liter.
Hmm. That would
Got
be
my
the
point?
concentration, right?
Yeah. So that is molarity. So now if I divide this entire into 6 portions,
Hmm.
each,
Hmm.
what would you say? It would be 3 moles
Hmm.
per liter.
Yes, ma'am.
Got my point on it.
Yes, ma'am.
Any doubts?
No, ma'am.
Got it?
Yeah.
So that is the concept,
Yes.
right? So you understand that if you assume that even distribution is there,
Hmm.
so assuming even distribution, how many moles per liter would you find? That will be 3 moles here, 3 moles here, 3 here, 3 here, 3 here. And in all, total 80 moles.
Yes, ma'am.
So how many moles of solutes you are getting per liter? That is molarity.
Okay,
Are you
ma'am.
understanding?
Yes, ma'am.
Got my point?
Hmm.
Got my point?
Yes, ma'am.
Right. So that is the concept. Now, let's suppose if I say that, now in this given solution where I had added 6 liters of water, now there was a 6 liters of water in the solution, right? And I had added 18
Moles
moles of
of
sugar.
sugar.
You understand? Now, let's suppose
Yes,
if you
ma'am.
add, that was 18 moles of sugar. Got my point?
Hmm. Yeah.
So, let's suppose if I add, uh, let's say 6 liters of water more.
Hmm.
You understand? Now, if I add
Yeah.
6 liters of water, so what am
Hmm.
I doing? I'm kind of increasing the volume. So that becomes 12
Yeah.
liter solution.
Hmm. So
So in
that would
12
make
liter
that would
solution, it would
decrease.
have 18 moles of sugar because sugar, so I have not added.
Uh,
Sugar is still the same. I have just added
hmm.
water from outside.
Yes, ma'am.
So what do you think we have? We have 12 liter solution. And when we have 12
Concentration
liter
is half.
solution, we would have 18 moles of sugar into it. So how much per liter of sugar do we have? 18 by 12.
1.5 moles.
So 2 6 are and 2 9 are.
Hmm.
3 2s are. 3 3s are. So that is going to be
Hmm.
1.5
Yes,
moles
ma'am.
per liter. Are you understanding?
Yes, ma'am.
Got my point. So now you tell me, when you add water from outside,
Hmm.
adding water from outside shall do what?
Decrease the concentration.
Right. So adding water from outside shall increase the volume, but
Hmm.
moles per liter
Shall decrease.
shall decrease. Are you understanding?
Yes, ma'am.
Got my point?
Hmm.
Right. That is the concept.
Yes.
Any doubt in this?
No, ma'am.
Sure. So
Yes,
that
ma'am.
is the concept.
No doubt.
So that is the concept. So can I say with dilution,
Yeah.
molarity,
Decreases. Yes, ma'am.
molarity decrease?
Hmm.
Are you understanding?
Yes, ma'am.
Any doubts in this?
No, ma'am.
Got the point?
Yes, ma'am.
Right? That is the point. Got it or no?
I got it, ma'am.
Right? So understand one
Hmm.
thing. So earlier the molarity one was 3 moles per liter.
Hmm.
Then volume one was 6 liters.
Hmm.
Now the molarity two is 1.8 moles per liter
Huh.
and volume two is 12 liters. So
Yeah.
if I multiply this, what do you think is going to happen? Sorry, the
18.
new
You,
molarity would be how much? 1.5.
yeah, 1.5.
So if you multiply M1 into V1, you will get 18. And if you
M2V2.
multiply
Yeah.
M2 V2, that shall also be 18.
Hmm.
What exactly does that mean? That if we multiply, so how do you define molarity? That is the number of moles of solute
Hmm.
upon volume of
Solution.
solution. You understand my point?
Hmm. Yes, ma'am.
Got it?
Hmm.
Yes or no?
Yes, ma'am. I got it.
So molarity 1 into volume 1 shall be number of moles of solute.
Hmm.
And
Okay,
similarly,
ma'am.
if you multiply molarity of any solution into volume, that shall also give you the number of moles of solute. So what do
Mm-hmm.
you understand from this? M2V2 is again giving you that. That means after dilution, what is not changing? After dilution, we know that volume increases,
Hmm.
molarity also increases,
Molarity decreases.
molarity decreases, but M into V remains constant.
Hmm.
Are you understanding?
Yes, ma'am.
Got my point.
Yes, ma'am.
Any doubts?
No, ma'am.
Sure?
Yes, ma'am.
That is the concept. Any doubts?
No, ma'am.
Got it? So V shall increase, M shall decrease, MV shall remain constant. That is the
Constant.
point. So I would say that molarity can change, but and what does MV gives me? It gives me the total moles of solute.
Hmm. Yes, ma'am.
It gives me the total moles of solute
Hmm.
that is to be added.
Yes, ma'am.
Understood or not?
Yes,
Yes or
ma'am.
no?
Understood.
Right? So total number of moles of solute never changes during dilution.
Hmm.
Understood or not?
Yes, ma'am. Understood.
Got it?
Hmm.
That is the point. Right?
Yes, ma'am.
Right? So this is molarity.
Hmm.
Okay. Now understand. How does molarity depend upon how does molarity change with temperature? Now see that. How does molarity
Ma'am, so temperature is directly proportional to volume. So molarity would decrease.
there are two cases.
Okay.
See, let's suppose if I have an open container.
Hmm.
So in open container, if you heat the solution and there is sugar into that,
Hmm.
what do you understand?
Like some of it may escape,
Right.
evaporate.
So if water evaporates, obviously the volume of solution shall decrease, and molarity is
Yeah.
nothing but the number of moles per volume. So in the
So
open container,
molarity would
volume shall
increase.
decrease, molarity will increase.
Hmm.
In the closed container,
Hmm.
what do you understand? In the closed
Like.
container, the volume, let's suppose this much was the volume of the solution.
Hmm.
Let's say
Hmm.
this much was the volume of the solution.
Hmm.
You understand?
Yes, ma'am.
So if this was the volume of the solution, what do you understand from this part?
Um, there would be some expansion due to heat, thermal expansion.
Yeah,
So the volume would increase, so the
right,
molarity would decrease.
exactly. Molarity would decrease means if I define molarity, it would mean that the kind of the taste that I'm having for the sugar solution. So
Hmm.
you must have seen that the hot sugar solutions they tend to uh, become less sweet
Hmm.
or less sweet. Why so?
Because the constant molarity of sugar itself decreases, so there is less moles of sugar per liter.
Right.
So hence, it would be less sweet.
Got it. Yes or no? Because the sugar that was
Yes,
being dissolved into this part would now be
into
spreading in
the
a
whole part.
little bit more area.
Yeah.
So per liter moles would decrease there, and hence molarity will
Yes,
also
ma'am.
decrease. So you have to
Hmm.
understand that molarity, but the default case is the closed container.
Mm-hmm.
Is that clear?
Yes, ma'am.
Got the point,
Yes, ma'am.
right? Okay. Now that's the concept. So would that be enough for the demo?
Hmm. Okay, ma'am.
All right. So this is molarity, and going forward, we will be having other concentration terms as well, right?
Hmm.
That's it.
Okay, ma'am.
All right.
Uh,
Understood?
yes, ma'am.
Okay.
Bye, ma'am.
Bye.